Okay, so section 4.4 is on the slope of a line. We say that slope is the relative steepness of a line. It's how much does the line rise, how steep is that rise for the run. That's why we like to say slope is rise over run. Change in y over change in x. And really, however you write the formula, it doesn't matter whether you put y sub 2 minus y sub 1 over x sub 2 minus x sub 1 or the other way around. You'll get the same answer for the slope. If they ask us to find the slope between the 2 points negative 3, 0 and negative 1, 6, we're going to determine which point am I going to call point 1, which point am I going to call point 2, and then in this case it looks like y sub 2 is the 6, so I'm going to call this x sub 2 and I'm going to call this y sub 2, and I'm going to call this x sub 1, and I'm going to call this y sub 1. So that's point 1 and point 2, point 1 and point 2, and then I'm now going to plug those into the equation and solve. And my slope here is going to be 3. Again, it doesn't matter which one you put first. If you flip those x's and y's around, if you flipped point 1 and point 2 around, you'd still get the same slope. So when you plug that 0 minus 6 over negative 3 minus negative 1, you're going to get a negative divided by negative is a positive. You still get a slope of 3. All right, so basic definitions. Positive slope goes up to the right on your graph. What kind of slope would this be? Well, it's going down to the left, so obviously it's going to be negative. And this problem would be exactly the same as the example that we just gave before. We would choose which point is going to be point 1, which point is going to be point 2. I'd probably call this point 1 and this point 2, making the negative 2 the x value for point 1, the 1 is the y value for point 1, the 1 down here is the x value for point 2, and the negative 3 is the y value for point 2. So at that point now, I'm going to go ahead and plug that into our equation, and our slope is going to be negative 4/3. So yes, the negative 4/3 slope is going to go down to the right. And one final example. In this one, you should notice right off the bat that the y values are the same. And so if the y values are the same, the numerator is going to go to 0. And when the y values are the same, we say it has a 0 slope. Now don't get this confused with when the denominator goes to 0 and it becomes undefined. If you call a 0 slope problem undefined, you're wrong, just like if you call an undefined slope problem 0, you're wrong. So here's the graph of that line, and it's going to be a horizontal line. And a horizontal line is flat, so it has 0 slope. And then, of course, in this last example, you're going to see that the x values are the same. And when the x values are the same, we get an undefined slope because the denominator goes to 0. And we all know at this point you're not allowed to divide by 0. That's a vertical line. Okay, so what are all the possibilities for different kinds of slope? We can either have positive slope that's going to rise to the right. We're going to have negative slope that's going to fall to the right. We have horizontal lines that have a 0 slope, and we have vertical lines that have a slope that's undefined.